Like, if you're in a spaceship and it's going 0.9 the speed of light, and you take a bullet that's also going to fire at 0.9 the speed of light, if you lean out the window and fire it forward, from your perspective, it does go 0.9 the speed of light. Even though, from the inertial observer, from the guy at the starting gate, his perspective is, oh, this is weird. Bullet. Amazing gun will shoot your bullet at 0.9 the speed of light. Okay, and when you're at 0.9, if you shoot the bullet off at 0.9, I believe, I'm not sure. This gets into frames of reference. I know that if it was light shooting out of that gun, the light would seem to go at the speed of light. Would the bullet seem to go at 0.9 the speed of light? Or would it seem to just kind of sit there in your gun? Maybe it would sit there. If it's going to sit there, that makes sense. If it also shoots off at 0.9 from your perspective, then from the perspective of the guy at the starting gate, if you're going at 0.9 and if you shoot this thing off at 0.9, well, it can't possibly go further. It can't possibly go more than the speed of light. So its distance from you can only be so much. So then let's say you had a big claw on the front of your spaceship, and let's say it swoops the area where the initial observer expects the bullet to be. Because he thinks this guy's 0.9, this one's going at the speed of light, there's and a little distance between them. And so if you have this big claw, and it grabs for the bullet, is the bullet there? Oh, but from the perspective of the spaceship, the bullet's way out here. Where is the freaking bullet? What if you had an observer sitting in space, 2 spaceships, a nice hotel, and and the 2 spaceships each shoot away from each other at 0.9 the speed of light. Now, from my perspective in the space station, okay, if you're in the space station, that guy goes off that way at 0.9 the speed of light, that guy goes off that way at 0.9 the speed of light, which is kind of weird because then I know that the distance between them should be increasing at greater than light speed. Is that okay? Could you have a string between them then? If you had an extremely flexible string, what would that be like? 2 guys at 0.9 light speed is still okay. I'm not going to 1.1 or something crazy. If you have one in a string, and then the 2 ends of the string be moving away from each other, and let's say you had sensors in either end of the string that determine how much it's been stretched out by measuring the molecules on that end of the string, and then you could communicate faster. No, you wouldn't actually communicate. It's weird. Apparently information can't travel faster than light, although 2 parties several light years apart from each other could know the same information at the same time if it had been foretold or something. I don't know, I'm getting different things. So 2 spaceships go off. I've seen 2 guys go at 0.9 speed of light away from each other for 1.8 distance overall. But the guy in the spaceship, now he's going to see the space station rocketing away from him at 0.9 the speed of light. And he's going to say the other spaceship, because it can't violate light speed, the other spaceship is going to be going at nearly light speed. So here I am with my full light speed, my 0.9s and my 0.1s again. He shoots away, and what he sees is there's the space station, and if he assumes himself to be an inertial frame of reference, the station shoots away, and then this other guy shoots away slightly further. The other guy, meanwhile, is seeing the exact opposite thing. The both of them think of the other as being relatively close to the space station in comparison to himself. So the guy in spaceship A says, wow, I'm so much further away from that station than the guy in spaceship B is. And the guy in spaceship B is like, wow, I'm so much further away from that station than the guy in spaceship A is. Even though you can't radio communicate to tell each other this, you could just know, if you knew the schedule of who's going to fly when, you could be like, he must be this close. And he must be this close. And I must be far. No, I must be far. No, you're both far. Does someone think they're both close, too? Does someone... Huh. And then again, if they both stop, and they both send out slow motion probes, so there's no time dilation or whatever, who's near and who's far? This feels like quantum mechanics again, where we just totally don't know until we take a look. Or something. Wouldn't that be great if I just discovered the link between relativity and quantum mechanics? I kind of doubt it. Though I still think that the second law of thermodynamics is bunk. Yes, I've just lost so much support again from among science people. I'm going to do a video on that later. I don't not get the second law of thermodynamics, that is, as it applies to the universe. To any man-made machine, yes. The whole universe, that apparently isn't what's happening. Despite, the fact that it would seem obvious it would work. I don't think we're degenerating. I think we're anyway. Yeah. Things start moving at light speed. We just sort of screw with reality, and something's here or it's there. That also feels like one. Anyway, here's there's moving, not. Time changes. Time warps around. Throw in some extra dimensions of space, but they're folded. Then throw in some time, maybe. Extra dimensions of time. Time travel, wormholes. That giant void they found. Possibility of alternate universes. And the breakdown of determinism that occurs in quantum physics. That one's very interesting. Very interesting. Okay. No answers here, just a lot of questions. Thanks for watching. See you later.